This is your IT center, right? And this IT center has a video conferencing hall with it. And it is not an ordinary facility. It is an excellent facility. And in 2009 and 10, I did 2 courses from America using the video conferencing facility in this university. So if you have friends, you have teachers, and who are ready to teach in your department through video conferencing by not physically coming, because there was a lot of terrorism and different things in Peshawar in those days, and I had a contract, a promise with the American university that their teacher will come here and teach us 2 semesters, full courses. But because of that security condition, he didn't come, and he taught that course 90 minutes every day for 32 days through video conferencing facility. So it is an excellent facility, and we must utilize it instead of just using it for our meetings. This is the scanning electron microscope, right? I cannot open it. In the old days, we used to have some chambers and then pull them out. When the pressure inside the machine equilibrated, then we put the sample in and then we push it inside there. So this is the sample chamber. Your sample is here. I am not opening it because it is running now, right? This is the pore, the aperture. The aperture change. You can change the aperture. You are looking into this much area, or you are looking into this much area, or you are looking into smaller area. So you can select it to aperture. The smaller the aperture, the fine will be the resolution of the machine, because you are looking into the smaller area. Here, this thing is the detector. EDS detector, energy dispersio electron, energy dispersio X-ray electron spectrometer is here. The electron hit the sample, they generate X-ray. Those X-rays are detected to tell you about the elemental composition of the material. Here, I have forgotten it for a long time, I didn't use these. But this is the brightness, this is the contrast. You can change it, and this is coarse magnification and this is fine magnification. Yeah, so you can, when you, this is focus. This is focus, right? So you can, if you remember, I used to tell you that when you defocus things, their resolution increases. It is not the case in the SU. It is the case in the TM. When you are looking into angstrom level features, I told you that if it is like this, then these rows are very thin. But if you slightly defocus it, what you do, you increase the length for the radiation to pass and come. When it is like this, it is very thin area, but if I move it, defocus it, this area increases for the radiation, not in practice, but for the radiation, and this void appears wider. So when you are making Fresnel fringes for finely resolving features in the transmission electron microscope, then you do it through defocusing. Like here, that when it is fully focused, it is small gap, but when you defocus it, it increases and changes the features. The magnification is here, so you can move it and then you see at very high magnification you can't focus it. Then we go to fine focus. لكن فضول چې ته خفه کېږې نه
بایولوژي کې سامپل د ټول رینج
ها نو بس دې کې بیا هغه نشته You see, you can see various features, thicknesses, widths, pores, variation in contrast. But when it is secondary electron scanning electron microscopy, it is giving you microstructural contrast. The variation in the morphology, the variation in the feature dimensions, things like that, you can say. But when it is backscattered electron microscopy, that gives you compositional contrast. So if you have titanium rich particle and barium rich particle, its contrast will be different. And never say black and white. When you are explaining the microscope images, never say black and white. Say dark and bright, because it is contrast. They are not colors, right? So these dark features, either they are because of composition, variation, or because of the level of that feature. If this level is down, look at this finger. These areas appear to you bright, but these whites appear to you dark. Why? Because light is absorbed here. So here, if you see a darker feature, it is the absorption of the beam. More beam is absorbed here. Here, less is absorbed. That is why you see bright. Right? And you select a specific area of very small size. I am not doing that, but here you can take the EDS spectrum. The EDS spectrum gives you the elemental analysis of that particular spot or feature. You can encircle it, you can take the whole sample by like this, right? You take the whole sample, get the gross composition of the sample. You can select specific features and know about. Many students are doing MPhil and PhD, and when you ask them that you are showing this micrograph, what is this? Then they don't tell you, because they have not done EDS of their sample. They did all the MPhil and PhD work, but when you ask them what is this material, they can't tell you with authenticity, because they don't do XRD of the sample. So if you have not done XRD, if you have not done EDS, then why are you showing pictures and materials? Because the first thing is that if you show a certain material and tell me this is that, and I ask you how can you prove it, and you have no proof, then you are lying. If you have the facilities, do it, right? If you are not doing it, this means you are concealing the facts. Your material is not that material, and you are telling me that you have that material. So always utilize all the techniques you need to authenticate, to strengthen your argument of what you say in your thesis. But never use a machine which you don't need it. If your issue is solved by an optical machine, then why waste the resources of highly expensive machines for nothing, right?